What if I told you that every single particle in the universe has a hidden twin, a heavier shadow version of itself that we've never ever seen? Well, today we're diving into an idea called supersymmetry, and it's so elegant, so powerful, it might just be the key to solving the deepest mysteries of our entire cosmos.
You know, way back in 1897, the painter Paul Gauguin scribbled these exact questions onto one of his most famous paintings. And what's absolutely fascinating is that over 100 years later, these are the very same questions that drive fundamental physics. They are the engine pushing us to figure out, once and for all, what this universe is actually made of.
All right, so here's our game plan. We're going to start with what we know for sure, then look at the huge puzzles we don't know, and finally explore this super new idea that, honestly, could change everything.
I mean, for as long as we've been human, we've been looking around at this incredibly complex world and asking a simple question. Can all of this be broken down into a few simple, fundamental ingredients? It's the ultimate quest.
See, an artist like Gauguin, he explores these big questions through a really personal, internal lens. But science offers us a totally different path. It gives us this strict, rigorous method to find answers that aren't just personal, but that we can all test, verify, and agree upon. It's where imagination meets cold, hard evidence.
So that quest for answers, it led us somewhere incredible. It led us to our current, and I mean unbelievably successful theory of reality. It's called the Standard Model, and it's basically our rulebook for the entire subatomic world.
Think of it like this. Imagine you could pop open the hood of the universe and see all the tiny little cogs and gears that make it tick. That's the Standard Model. It's our complete picture of all the fundamental particles and the forces that govern them, and it's not just a nice idea. It is the most stringently tested, mathematically precise theory in all of science.
And when you dig deep down into this beautiful, complex theory, this entire universe, it all boils down to one surprisingly simple number: 3.
And this is it's just so elegant. Think about it. Everything you have ever seen or touched in your entire life, you, me, this planet, the most distant star, it's all built from just these 3 little things. You get a couple of up quarks and a down quark, they make a proton. A couple of down quarks and an up quark, you get a neutron. Throw an electron and boom, you have an atom. You have everything.
The Standard Model is, without a doubt, one of humanity's greatest achievements. You can think of it as Book 1 of the universe's instruction manual. It's this incredible guide that perfectly tells us how everything works.
But here's the thing about Book 1. It's got some pages missing. In fact, it has some massive plot holes. There are these huge cosmic mysteries that the Standard Model simply has no answer for. And that's forcing us to look for what comes next.
For instance, astronomers can see the gravitational pull of all this invisible stuff they call dark matter. It makes up most of the universe. But the Standard Model, it has 0 particles that could be it. It also can't explain why we're here at all. The Big Bang should have made equal amounts of matter and antimatter, which would have just annihilated each other. And it doesn't tell us why particles have the specific masses they do, or how to get all the forces of nature into one unified theory. So here's the bottom line. Science is at this amazing turning point. We've gotten really good at describing how the universe works. But the next great challenge, the next frontier, is to understand why. Why these specific particles? Why these particular rules? And for that, we're going to need a new book.
So what is the leading candidate for the first chapter of Book 2? Well, physicists have this idea, and it is just breathtakingly beautiful. It's called supersymmetry.
So, supersymmetry suggests that there's this deep, fundamental symmetry woven into the very fabric of nature. The core idea is that the laws of physics don't actually change if you swap out certain types of particles for others. And the most stunning consequence of this idea? It means every single particle we know of has an undiscovered twin, a superpartner.
This idea literally creates a shadow world. So for the electron, there's a selectron. For the quark, there's a squark. For the photon, a photino. Now, yeah, the names are a little bit silly, but the concept is profound. It basically says that for every matter particle, what we call a fermion, there's a corresponding force particle, a boson, and vice versa. It perfectly doubles the entire particle zoo, creating these beautiful pairings.
And here is why physicists get so excited about this. It's not just a neat mathematical trick. Supersymmetry offers real potential answers to those huge puzzles we were just talking about. It could explain why particles have the masses they do, and most exciting of all, it gives us a perfect, ready-made candidate for dark matter.
Which, of course, brings us to the biggest question of all. If this hidden world of superpartners is real, then where are they? How could we possibly find them? I mean, it's the elephant in the room, right? It's the central challenge to the whole theory. If the universe is fundamentally symmetric, and every particle has a twin, you'd think the cosmos would be teeming with them. So, why are they totally invisible to us? Well, the theory gives us two amazing answers. First, most of these superpartners were probably incredibly heavy and super unstable. They would have existed for just a fraction of a second after the Big Bang and then decayed away. But, and this is the absolute kicker, the theory predicts that the lightest one of them all, the LSP, would be perfectly stable. It couldn't decay into anything else, so it would still be here, today, floating all throughout the universe. A heavy, stable particle that doesn't interact with light. You got it. It is the dark matter.
And so right now the hunt is on. Deep underground at CERN, scientists at the Large Hadron Collider are smashing particles together at mind-boggling speeds. They're trying to briefly recreate the conditions of the Big Bang itself, hoping that for just a fleeting moment they can create these superpartners and finally catch a glimpse of this hidden world.
And the stakes here, they couldn't be higher. As the brilliant physicist Edward Witten says, discovering supersymmetry wouldn't just be another little step forward. It would be a true milestone in physics, one that would completely rewrite our understanding of space, time, and reality itself.
Which leaves us with this one final, mind-bending thought. Are we right now standing on the edge of discovering a whole new layer of reality? A hidden, perfectly symmetric world that has been sitting just beneath the surface of our own, right since the dawn of time? We don't know the answer yet, but it could be just one collision away.